So now we are finally going to do inverses. We're finally going to find the inverse of a function. Now, before we start finding these inverses, I do want to go over one thing. So, can you see that? Is that okay? Let's change it. There we go. All right. So, when I have an x and y axis, and I ask you to find the inverse of this point. So this point is located at 2, -1, right? Where do you think the inverse of that point is? Not quite, nope. Close. No. What? Close, you're getting closer. So we're switching x and y. -1, 2. Yes, the inverse of this is at -1, +2. Oops. -1, +2. Stop it. Right here. Now, what did we do to get that inverse point? Ah, flipped x and y. Good. So now, let's find the inverse of this point. This is at what? 1, 2, 3, 4, 5. 2. Where's the inverse of that point? 2, 5. What about this point? This is at 1, 2, 3, 4, 5. -5. Where do you think the inverse of that point is going to be? -5, 1. So, what does it look like these points are doing? If I were to compare the inverse to the original, the inverse to the original, inverse to the original, what does it look like is happening here? This is thinking back to geometry, actually. Yes. It's what? Yes, oh my gosh. So, what is literally happening when we're finding the inverse is we are reflecting the points over a certain line. Which line are we reflecting over? Yes, this line right here, right? Oh, that's not big enough. If I were to fold this graph along this line, would all these points line up? Oh, yes, they would. Every single time you're being asked to find the inverse of something, you're actually reflecting over y = x. So, for example, if we had, let's do, if we had this parabola right here, and I asked you to find the inverse of that parabola, what would you do? And how would we reflect it? So what could you do? What did we do with the points? What did we do with all those points? We switched the x and y. So our first perfect point is at 0, 0. Where is the new one going to go? It remains at 0, 0. Our next perfect point is at 1, 1. Where's that going to go? It's going to remain at 1, 1. Our next perfect point is at -1, 1. Where is that going to go? 1, -1. Then we have 2, 4. Where's that going to go? 4, 2. Then we have negative 2, 4. Where's that going to go? 4, negative 2. So look. This is my new parabola. If I were to fold this paper along that orange y equals x line, would these graphs line up? Yes, they would. We just reflected over the line. So all that we're doing today is, instead of on a graph finding the inverse, we're finding the inverse algebraically. Okay? Now, what did we do to find the inverse points? What did we do? We flipped what? The x and y. The exact same concept applies algebraically, okay? So here, our first step is to change f of x to y, because we are dealing with y's, and it just makes things easier. So instead of f of x, I'm going to write y equals negative 2x plus 5. And the second step is to switch your x and y's, just like we did for the points, right? We switch x and y. So instead of it being y equals, it's now going to be x equals negative 2 times y plus 5. So we're taking a function and trying to find the inverse function. What do you think we need to do from here? Is this how a normal equation looks? X equals negative 2y. What do you think we need to do? Get y by itself. So how do I do that?
Subtract 5.
Yeah, you subtract 5. So it's going to be x minus 5 is equal to negative 2y, then what? Divide by negative 2. So either you can leave it like this, or you can write y equals negative 1/2 x plus 5/2. Now above, is that our last step?
So we could leave it like that, kind of?
Yeah, you could leave it as y equals negative x minus 5 over 2.
Okay.
But this is in standard form. So is that step number 4 completed? What does step number 4 say? Yeah, change the y to the inverse function, f negative 1 of x. That negative 1 means what? Inverse. And we're done. That's it. This is how you find the inverse of a function algebraically. Yes?
Could I flip x and y first? Could I solve for x first and then flip them?
Yes. Yes, you could. Any questions? All right, then you guys try the practice problems. So if you have two functions and f of g of x and g of f of x both equal x, then the two functions are inverses of each other. This is how you can check to see if they're inverses. So let's try it. We have f of x equal to x plus 6 and g of x is equal to x minus 6. So first we'll do f of g of x. So is there a value I'm replacing x with in g of x? Or is it just staying x? It's just remaining x, right? So I'm taking g of x in its plain form, which is x minus 6, and I'm putting that into f of x. So I'm taking x minus 6 and putting it into f of x and replacing x minus 6. I'm replacing x with x minus 6. So this is f of x, right? X plus 6. I'm taking the x and replacing it with what? X minus 6. So this becomes x minus 6 plus 6. And what is x minus 6 plus 6? What two like terms can I combine there? The 6's, right? -6 and +6 make what? Yeah, it's just -6 plus 6 is 0, so you're just left with x. So this one checks out. Okay, this one is equal to x. So now we need to check the other one, g of f of x. So now we're taking f of x, so x plus 6, and plugging it into g of x. So I'm taking x plus 6 and putting it in instead of x. So now, what does this become? What does g of x become? Yes, x plus 6 minus 6. And what is 6 minus 6? 0. So it's just, so these, are they inverses of each other? Yes, these are inverses of each other. Meaning, if we were to graph them on a graph, they would be the reflection of each other over the line y equals x. Does this make sense?
Yes.
This is probably, you know, everything we've done today is accumulating here, right? So this is the hardest concept, knowing what needs to substitute into these equations. Do you need me to do one more?
Yeah, do number 4. 4 is always the hardest one.
All right, number 4. So we're first going to do f of g of x. So I'm going to take g of x in its entirety and put it in for x in f of x. So -1/4 x plus 2 is going to replace x wherever we see it. So it's going to be 4 times -1/4 x plus 2. And then we can't forget about that plus 8 on the end. So what are we going to do first here to simplify? Do you think? What would you do first here on the end to simplify this? Yeah, you distribute the -4. So this becomes, what's -4 times -1/4? A 1. So it's just x. And then -4 times 2 is -8. Well, what's -8 plus 8? Cancels, and you're just left with x. So that works. So now we have to do g of f of x. So we're going to plug in f of x in its entirety into g of x. So now wherever we see an x, we're going to put -4x plus 8. We can't forget about that plus 2 on the end. So what am I going to do first here? Again, distribute. So what's -1/4 times -4? 1. So we are left with x plus, oh, what's -1/4 times 8? -2. So what am I left with here? What's x minus 2 plus 2? So are these inverses of each other? Yes, these are inverses. Does this make sense?
Yes.
All right. So your job is to do 1, 2, 3 here. And also when you're finished with this, go ahead and tape it in your notebook on page 36. And then your homework is the half sheet. Now, this was taped in on page 35.
Okay.